Hi, in this video we will learn how to define the values of trigonometric functions for a general angle theta. Well, so far what we learned is that if an angle is between pi over 2 and 0, this is called acute angle, then we can use right triangles to define trig ratios of theta, yes, trig ratios or trig functions of theta. But how about angles which are bigger than pi over 2? How about negative angles? Well, you may say, what is negative angle? Well, we have to make sense of that, and everything will start from that point. We have to make sense of negative angles and how to position an angle on a coordinate system, and then from there we will define trigonometric functions for that angle. So then let us start with standard position of an angle. So standard position means that what is the best way to put an angle on coordinate system, meaning that, well, if I have a coordinate like this, let me make it a little bit bigger. If I have a coordinate like this, how I should position an angle into this which will be useful for us. This is called standard position. Well, when we have angles, we have basically two sides, one side and another side. Both of them intersect at the vertex. If you put vertex at the origin of the coordinate system and put one of the sides on the positive x-axis, we call that side initial side. So initial side's always on positive x-axis and vertex is always at origin. Then the next side, the other side, we call it terminal side. It can be anywhere on this coordinate system. Yes, it can be this or in any other quadrants. What is important with this notation is that you basically see angle, a rotation from initial to terminal. And if this rotation is counterclockwise, we say that that angle is positive. If it is counterclockwise, we say it is negative. So let me just write it here: positive angle and negative angle. Positive angle is an angle that the rotation from initial side to the terminal side is counterclockwise. So if it is counterclockwise, it is positive. If the rotation of the initial side to terminal side is clockwise, the sign of the angle is going to be a negative one. So in other words, this guy here is a positive. However, this example, let me draw this one here. this one here and then some other one here. If we go, the rotation is this way, this is a negative angle. Positive angle, negative angle. Positive is counterclockwise. It's very important. Counterclockwise is positive. Clockwise is negative. Let's do one example before we proceed to define trig values, trig functions for this general angle. Example, find the standard position of the given angle. Well, I have several of them, pi over 2, then a negative pi over 6. Yes, angles can be negative now. 2 pi over 3, negative 4 pi over 3, and then I have another one, 9 pi over 4. Okay, so let me just put coordinates for each one of these ones. Paste. Then another one. Another one. And this is the last one. Okay. So all of them, the initial side is on positive x-axis. This turned to red, so let me just use the black one for this one. And what happens here is that now positive means that we are going to go this way, negative means that we're going this way, positive is this way, negative is this way, and positive means we go counterclockwise. That's the direction. Now, pi over 4, you know pi over 4 is 90 degrees, and it is here. So we go from this to that, that is pi over 2. Pi over 6, well, you can fix this in different ways. One is that pi over 6 is 30 degrees, so 30 degree is 1/3 of 90 degree, or pi over 6 is 1/3 of 90 degrees, so it is almost there, so I can do this one. So this is the theta, so ignore this other one here. Okay, so that's the angle. 2 pi over 3, it means that 2 pi is full complete revolution, 1/3 of that, so it will go somewhere here, and it's positive, so it will go this way. 4 pi over 3, so one way to see this thing is that while you can see this as negative, there is a pi, so this is half revolution, plus pi over pi over 3. So first this goes up to here, this is pi. Then there will be an excess of pi over 3. Pi over 3 is 60 degrees, so it will be somewhere here. So this whole thing is negative 4 pi over 3. And the last one, this 9 pi over 4, you can see that this is 2 pi plus pi over 4. What does it mean is that, well, you have to go once around a complete revolution. So far, this is pi over 2 pi. Then there will be another pi over 4. Pi over 4 is half of 90 degrees, so this will go up to there. So that is the terminal point. Well, practice a little bit, you will see that you need to be able to do this. Why? Because this is how we define definition of trig functions at theta in general. So what you do, pick any point on the terminal side of the angle. This is when it is in the standard position. So you already put it in the standard position. Find any point on the x on the terminal line. So let me just do one thing here. Paste. This is good one. So what we do, we have this. The angle is, let's say, from here. This is always a standard. Is this? Then you go somewhere. Well, doesn't matter wherever it goes. So this is theta in a standard position. Pick any point on this terminal side. Okay, then the distance of that point from the origin we denote it by r. When you know that by Pythagorean theorem, this is x squared plus y squared and then square root of that. Now you have x, y, r. You use this formula. Sine of that angle is equal to y over r. Cosine of that angle is x over r. Tan of that angle is, well, as always, sine over cosine, which is y over x. Cosecant theta is 1 over sine, which is r over y. Secant of theta is 1 over cosine, which is r over x. And cotant theta is 1 over tan, which is x over y. So this way, we define all trig functions for any given theta. Positive, negative, doesn't matter. You just find one point at on the terminal side, and then that's it. Use these formulas and define the trig ratios. Okay, let's do an example. Find values of all trig functions, all 6 trig functions at theta negative 5 pi over 6. So it means what? It means that first we have to find the angle in the standard notation, standard position. So let me do this first. Okay, this is my coordinate system. These are the ones. Now negative pi over 6, I have to put it in standard position. So initial side is on positive x-axis, and then it is negative, so it will go clockwise. But how do you see this thing? This is 5 pi over 6. So you can see, while the negative sign is off there, this, you can see that this is 5 of pi over 6. Means that, while pi over 6 is about 30 degrees, so this 1, 2, 3, 4, and 5. That's it. So let me just raise these other ones. So the standard position of this guy is this. This is negative 5 pi over 6. Now we need to find a point on this line, on this terminal side. How we can find a point on this? Here is where you have to use the reference triangles you had, meaning that, well, just remember that if this is negative pi over 6, this part here is going to be pi over 6. So we need another pi over 6 to reach this thing to the pi half revolution. So if that's pi over 6, remember we had this triangle, right triangle with one of the angles pi over 6, and the sides were 1, 2, root 3. So you have to remember those two reference triangles because we will use these ones. Okay, so this is a triangle, but what about the coordinates of that point? Well, you see this is going to be x. The distance of this to the origin is root 3, but it is on the negative side of the x-axis, so this will be negative root 3. And y is this part, so the distance is 1, but since it is down the x-axis, it will be negative. So now we know that x is negative root 3, y is negative 1, and r is 2. Now that you have those ones, you can go ahead and just find sine of negative 5 pi over 6 is y, here is negative 1 over r. Cosine of negative 5 pi over 6 is x, which is negative root 3 over 2. Tan of negative 5 pi over 6 is 1 over root 3. Well, both of them are negative. Rationalize, cancel the negative sign. This will be root 3 over 3. Well, cosecant theta is r over y. This is 2 over negative 1. Secant is the inverse of cosine. This is 2 negative root 3, and then you can again rationalize and get this. And here is a cotan of theta, which is 1 over, let me just write it this way, and that gives us just root 3. And that's what you need to know. And you have to be able to do questions like this, examples like this. Also, we can have examples that gives us one of the trig functions at the point. So find all values of trig functions at angle theta such that sine of theta is 1 over 6. Unlike the acute angles, here this can be more than one angle that has 1 over 6 as sine. We have to also know where this guy lives. So it is an angle between pi over 2 and pi. So we have to start with this and find all the other ones. So let me then start with, well, somehow positioning this angle in a good coordinate. Standard position is always here. The initial side is on positive x-axis, vertex at origin. Then a theta is between pi over 2 and pi. Pi over 2 is here, pi is here. So it means that the terminal line, the terminal side, will be on the second quadrant. So it will be something like this. And remember that sine theta is y over r. So if we take this thing, we can set y equal to 1 and r equal to 6. So let me just do this piece. We need to find 1 point, yes. So based on the information given, we can take this point at which the r is 6 and y is 1. If you have y and that, using the Pythagorean theorem, this will be 6 squared minus 1 squared. This is root 35. This is the length of this side. When it comes to the coordinates of this point, we have to note that this is the side, but it is on the negative x-axis. So this will be negative root 35. And y is 1, so it will go up, so it is positive. We have x, we have y, then we can find all the other ones. Sine of theta was 1 over 6. Cosine of theta is x, which is negative 35 over 6. Tan theta is 1 over negative 35. Cosecant theta is 6. Secant theta is negative 6 over root 35. Well, that's negative is from downstairs. And cotan theta is negative root 35. As you can see in this new definition, well, which is the definition of trigonometric functions, some of the trigonometric functions, some values can be negative and some values can be positive. Look at this guy here. This is positive, this is negative, positive, negative. It's better to know when these guys are positive and negative. So as the last piece of this video, sign of trig functions. What really matters here is that we have to see where the angle, the terminal side of the angle is positioned at, which quadrants. Because you see, if you look at the definition here, for sine and cosine, this r here is always positive. So the sine of x and y determines when sine and cosine are positive and negative. So this is what we learned. So these are first quadrant, second, third, and fourth. And well, what your book says, I like that. All students take calculus. How to use this sentence? Well, first of all, this just tells us what are the sign of sine, cosine, and tan. Note that the sign of the cosecant is like sine, sine of cosine is like secant, and tan and cotan have the same signs. So we only need to know these ones, the other ones are similar. This is all, so it means that all of them are positive. If the terminal lines in the first quadrants. Then, let me copy this. Then it says it is student. So it means that only the one which starts with S is positive. So sine is positive. Two other ones are negative. And this last one says what? This last one says T. So that means that tan is positive and two other ones are negative. Negative. and this says calculus. So cosine is positive, then the sine and tan are negative. So this is also something to keep in mind, which sometimes will be useful to know this information. So basically what we did in this video was to learn how to define sine, cosine, and all trig functions for general theta, and we saw that the important point is that how to position an angle in a coordinate system.